Hello my dear students. In this video, I'm going to discuss distance time graphs and velocity time graphs for linear motion. So, first of all, if we say that object is moving with uniform velocity, or you can say it is under uniform motion, its distance time graph will be a straight line having some positive slope. You can see a upward and upward sloping line. When the distance time graph is an upward sloping line, it means that its velocity is constant. How? When we study distance time graph, slope of a graph, slope is also called as gradient. Slope of a graph is equal to measure on y-axis divided by measure on x-axis. Y means vertical axis, x means horizontal axis. And when we draw a displacement time graph, we take time on the horizontal axis and distance on the vertical axis. That's why slope of distance time graph is nothing but distance divided by time, which indicates speed. So slope of a distance time graph gives us speed, and slope of a displacement time graph gives us velocity. Velocity is equal to change in distance upon change in time, s2 minus s1 upon t2 minus t1. Now suppose for this graph we have just said that velocity is constant. Now if we are being asked to find out this constant velocity by looking at this graph, how can we do? What will we do? We will take any two points on the graph. We will take on which we are knowing the time values as well as the displacement values. Okay. Now suppose we select 2 points. One we will select here at origin and another we will select here. So these are the 2 points which we have selected to find out the velocity of this object moving with uniform motion. Now what will we do? Draw a perpendicular line from this point, perpendicular line to the time axis, and note down the value of time here. So this will be equal to t2. Now draw a perpendicular line to the displacement or vertical axis and note down the value of displacement here. This will be equal to s2. So s2 is known to us now, t2 is known to us. Now what about s1 and t1? As we have chosen origin, so s1 will also be 0, t1 will also be 0. This is how, by measuring change in displacement upon change in time, we can find out the velocity of this uniform motion. Okay, so distance time graph, its slope indicates the speed. Displacement time graph, its slope indicates the velocity, and the area, that is, area means measure on y-axis multiplied by measure on x-axis, that is product of y and x. So product of distance and time, it's meaningless. Product of displacement and time, it's meaningless. Now when we encounter a distance time graph which is a horizontal line parallel to time axis, what can we interpret about this graph? When the displacement or distance time graph is a horizontal line parallel to time axis, as you can see here, it's a horizontal line parallel to time axis. So we can say that the object is at rest and it is stationary and its velocity is zero because the slope of distance time graph indicates the velocity and its slope is zero because it is parallel to time axis. Slope is zero, velocity is zero, object is at rest. Suppose if you have to find the velocity, what will we do? Take any 2 points over this graph. Take mark this point, then take this point. Again, this follow the same process. Draw one perpendicular line. This will be the T2. Draw perpendicular line perpendicular to time axis. This will be T1. Now from this point draw perpendicular line to the displacement axis. This will be S2. Now again draw perpendicular line from this point. This will be S1. So you can see that here S2 and S1 are same, so their difference will be 0. So you will get 0 velocity. So velocity is 0. Now how will we draw velocity time graph for this kind of motion? So we will draw velocity time graph. This will be the velocity time graph for this type of motion. When displacement time graph is horizontal line, then this will be the velocity time graph. Velocity is 0. So what will we do? We just simply draw a line on the time axis, which means at every instant of time its velocity is 0. So this is how we will draw a line on the time axis. Now when the distance time graph or displacement time graph is a straight line having some slope, it means that the object is moving under uniform velocity or constant velocity. Its velocity time graph would be like this. You will be having a horizontal line parallel to time axis. Draw a horizontal line simply parallel to time axis. So this velocity time graph corresponds to this distance time graph. When distance time graph is a straight line, it means its velocity time graph will be horizontal line parallel to time axis, which states that as time changes its velocity remains constant. Okay, then third type of displacement time graph or distance time graph, which represents the non-uniform motion. When the displacement time graph is a curved line, okay, then it indicates non-uniform motion. Non-uniform motion, in this case the gradient or the slope is increasing with time, so velocity is increasing. So we can say that object is under acceleration. Object is having acceleration. Okay, here we can say that from A to B we can see that the slope is decreasing, velocity is decreasing, so object is under retardation or deceleration. From B to C we can say that we can see a flat line, so we can say that slope is 0, or you can say velocity is, the slope of distance time graph is 0, means velocity is 0. Okay, this will be the graph then when velocity is 0. This is the graph when velocity is having some constant value. Okay, it will be above time axis. It will not be on the time axis, it will be above time axis. Okay, this is about 3 kinds of displacement time graph. Now we will see when the object is under non-uniform motion, whether the acceleration is uniform or not. So we will study if the velocity time graph is a straight line. It means the object is having different velocity, but its velocity is changing by equal amount in equal intervals of time. Now, what does the slope of this velocity time graph indicates? If you see velocity time graph, its slope means measure on y-axis upon measure on x-axis. Here on y-axis we have taken velocity, on x-axis we have taken time. So velocity divided by time is nothing but acceleration. So slope of the velocity time graph indicates acceleration. If it's a straight line, it means object is moving under constant or uniform acceleration, which is given by v2 minus v1 upon t2 minus t1. Change in velocity upon change in time to achieve that change in velocity. Okay, if the slope is a negative, or you can see a downward sloping line, it means there is constant deceleration. And when the non-uniform acceleration is there, then you will see the velocity time graph is a curved line. Here non-uniform deceleration, here non-uniform acceleration, because velocity is increasing with time, here velocity is decreasing with time. So now, what does the area of a velocity time graph indicates? Area will be equal to product of velocity and time, and product of velocity and time we very well know it gives us the displacement, and product of speed and time gives us the distance. So area under velocity time graph indicates displacement, and area under speed time graph gives us the distance. What about if we are having an acceleration time graph? Its slope is meaningless, but its area, which is product of a and t, it will give us change in velocity. Here it is written velocity, but it will give us change in velocity, as we had discussed in first equation of motion. We had derived first equation of motion is given by v is equal to u plus at, or v minus u is equal to at. So we can say that product of at is equal to v minus u, or we can say change in velocity. So the area of the acceleration time graph indicates the change in velocity. Now we will do one numerical. In this case, the position, this is a displacement time graph of an object, and its position at different times is shown to you. These a, b, c, d, these points are given to us. As it moves from a to b, we can see its displacement time graph is a straight line. When it is from b to c, it is a horizontal line parallel to time axis. Then again it's a straight line. So when it is moving from a to b, we can say that it is moving with uniform velocity. Straight line, velocity is constant. Okay, so it is having some velocity, but that velocity is constant because it is covering equal distances in equal intervals of time. Its distance changes by equal amount in equal intervals of time. So slope is measured on y-axis upon measured on x-axis, or you can say x2 minus x1 upon t2 minus t1. And this x2 minus x1 is nothing but displacement, change in displacement upon change in time. So it is nothing but it indicates the velocity. So we can say slope of distance time graph gives us the velocity. So if you have to find the velocity, we will find its slope, or we will see change in displacement upon change in time, x2 minus x1 upon t2 minus t1. Now what will be the value of x2, t2? Because the velocity is constant, we can choose any two points, or we can take any two instants of time. But as here we have to find the velocity from a to b, so we will choose a and b points. Okay, now from point b, draw a perpendicular line onto the time axis. Now this value will be equal to t2, so t2 will be equal to 5. Now draw a perpendicular line from point B onto the displacement axis. Now read the value where it cuts the displacement axis. This perpendicular line cuts the displacement axis. Read its value. That value is nothing but will be equal to x2. So x2 will be equal to 3. x2, write 3 in place of x2. Write 5 in place of t2. Now what will be the value of x1 and t1, as we have chosen this a point, which is nothing but the origin. So x1 is also 0 and t1 is also 0. So replace x1 by 0, t1 by 0. So velocity comes out to be 0.6 meter per second. Now from B to C, it's a horizontal line, which means object is at rest and velocity is 0. So you can simply write, or you can determine also. Again, draw the perpendicular lines. So in this case, you can see your t2. T2 will be equal to 7 and T1 will be equal to 5, but your x2 will be equal to 3 and x1 will be equal to 3. So if the numerator is 0, 0 divided by any number gives us 0, so velocity is 0. It comes out to be 0 meters per second. Now from C to D, it's again moving with constant velocity. So Again, we will choose 2 points C and D. They are already marked on the graph. From point D, draw perpendicular onto the time axis and note down the value of T2. It is 9, and draw perpendicular onto the displacement axis and note down the value of x2. It is 7. So x2 is 7, T2 is 9. Then from point C, draw perpendicular onto the time axis and note down the value of T1. It is 7. T1 is 7. Now draw a perpendicular onto the displacement axis and note down the value of x1. It is 3. So x1 is 3, T1 is 7, x2 is 7, and T2 is 9. Solve it, you will get velocity comes out to be 2 meters per second. Now if you look at these slopes and you will look at these angles which these lines are making with the horizontal line, we can say that whose velocity is greater. The slope of the line whose slope is greater, velocity will also be greater for that portion. So we can say that velocity as it moves from, it will move at a faster speed when it moves from C to D, and from B to C it is at rest, its velocity is 0. Okay, this is all for today. In the next video we will study velocity time graphs. We will solve numericals based on velocity time graphs. Till then, goodbye, bye bye.